All right, so for the drill today, what they'd ask us to do was to use the factor theorem to determine if the polynomial, the second one, is a factor of the first. So in order to do that, one of the things you could graph it and see if -1 is a 0, or when they're giving it to you like this, remember that in order for that to be a factor, that means that f of whatever the solution is has to equal 0. So when we have the factor being t plus 1, that means the solution was t equals -1. So we could do the polynomial of -1, plug that in our calculator, and we got -6. -6 does not equal 0, so it's not a factor. Down here, our polynomial is r minus 1, so that means r equals 1. So we're going to do p of 1, and we got -2, which again does not equal 0, so it's not a factor. Finally, these last two, same type of deal. W minus 1/2 means that W is 1/2. We evaluate. You may have gotten the decimal version of this. Either way, doesn't equal 0. It's not a factor, and neither is the last one. And again, all we did was we took our equation and typed it into Desmos with -1 being t. Today we're going to review fundamental operations of complex numbers in order to rewrite non-real solutions into quadratic equations. Imaginary number and its non-real zero number, imaginary number I, and its non-zero real number multiples bi are called imaginary numbers. This is because when they were first used, a mathematician had no concrete way of representing them. They are nevertheless a reality in mathematics, and important applications have been found for them in fields ranging from control processing to quantum mechanics. The definition of I is defined to be the square root of -1. Okay, so we have some simple things that follow from that. For instance, if I is the square root of -1, then what's I squared? Well, I squared is the square root of -1 times the square root of -1, which is -1. So then what happens if we want to do I cubed? Well, I cubed is I squared times I. So I squared is -1 times I. So I cubed is -I. And then I to the 4th is I squared times I squared. And I squared times I squared is -1 times -1, which is just 1. So those are just like cool, interesting facts about I. All right? You do want to remember that I squared is -1. You should know. Because I is the square root of -1. Start this show. So you want to remember that. So a complex number is a number of the form a plus bi, where a and b are real numbers, and I is the square root of -1. So for example, if we were supposed to show that the square root of -5 is I square roots of 5, what we would do then, two ways. One way we could do that is we could take I square roots of 5 and square it, because we're showing this is the square root. So when we square this, we should get -5. Well, I square roots of 5 squared is I squared times 5. I squared is -1 times 5, which is -5. Now the other way you could work that is say, okay, well, if I want to take the square root of -5, that's going to be the square root of -1 times 5. So what is the square root of -1? Well, the square root of -1 is I. Okay, so this is the work supporting the answer. This is the proof that shows. So you could work it either way depending on what it does. Now it says to solve. Now normally when we solve a quadratic equation, we use the quadratic formula, which is x equals opposite b plus or minus the square root b squared minus 4ac all over 2a. So we need to identify our a, our b, and our c, and then we plug it into the quadratic formula. Now me, myself, and I, the three of us, we like to do the discriminant part first. So I like to calculate what's under here before I do anything else. So that's probably what I'm going to do. So I'm going to do the b squared minus 4ac. So for us, that's going to be negative 2 squared minus 4 times 1 times 7. So that's 4 minus 28, which is negative 24. Since that's negative, since my discriminant is less than 0, that means I have no real zeros. So all of my zeros are going to be complex. Okay, there's nothing, everything's going to have an I in it. So what I'm going to do now is I'm going to take this 24 and it's going to go in for my discriminant. So I have negative b, so the opposite of negative 2, which is 2, plus or minus the square root of negative 64. So basically now what I'm doing is I'm breaking down negative 24. Negative 24 is negative 1 times 24. Breaking down 24. 4 times 6. Breaking down 4. 2 times 2. Breaking down 6. 2 times 3. I have a square root, so I'm looking for a pair of 2's. So that's going to be on the outside. I also have the square root of negative 1, which is I. So I'm going to have 2i and then the square root of 6. Now that's all divided by 2. So 2 divided by 2 is 1. 2i square roots of 6 divided by 2 is I square roots of 6. Notice we have the plus and the minus. We have both sets. Okay? So those are our two complex solutions. So now what we're going to do is we're going to do some practice with these. So basically when you add, subtract, multiply complex numbers, you're going to do just what it says. So it says z plus w. Z is 4 plus 5i. W is 2 minus 3i. And now we combine like terms. Nothing is here to change this. So we've just got 4 plus 5i plus 2 minus 3i. And then we're going to highlight our like terms. So I have a 2 and I have a 4, which is going to give me 6. And then I have like terms in my i's. I have 5i and I have negative 3i, which is going to give me 2i. So I have 6 plus 2i. Same thing when we are subtracting. But this time we have to distribute this negative through. So we have a negative 2 and we have a positive 3i because we distributed that negative. And we combine like terms again, same as we did before. Our constants go together and our i's go together. So this time it's 4 minus 2, which is 2, and 5i plus 3i, which is 8i. Now, when we multiply these, you do the same thing. You're just going to FOIL. So 4 times 2 is 8. 4 times a negative 3 is a negative 12i. 5i times 2 is 10i. And 5i minus 3i times negative 3i is 15i squared. So when you combine like terms, of course, these are your like terms. But what is I squared? Well, I squared is negative 1. So what we did here is we did negative 15 times negative 1 to give us positive 15. And then we combine like terms again. So we have 23 minus 2i. And then the last one, we're just taking and dividing by 2. So to write it in a plus bi form, we need a real part and an imaginary part. And then 4 divided by 2 is 2. Now, what could happen, though, is maybe you're not dividing by a number. Maybe this time you're going to divide by a imaginary number. So that's great. We can do that. When we divide by an imaginary number, though, we have to make sure that we get rid of all of the i's, because you can't have i's in the denominator because they represent square roots. So what you're going to do is you're going to multiply by something called the conjugates. So to find a conjugate, the only thing that's different is the sign in between. So the conjugate of a plus b I is a minus bi. And when you multiply these together, you're going to end up with a squared plus b squared, because your middle terms will always drop out. So if we want to express 4 minus 3i divided by 5 plus I in a plus bi forms, we want to rewrite it as a complex number. We're going to multiply by the conjugate of 5 plus I. The conjugate of 5 plus I is 5 minus I. So we're going to start out with this, and we're going to multiply by 5 minus I. So we FOIL the top. And then when we FOILed the bottom, we had a positive 5i and a negative 5i, and that canceled out. So here, this is really 25 minus negative 1. And this is really 3 times negative 1. So when we combine like terms here, that's going to be 26. And up here, this is going to be negative 3. And then you combine like terms. So we've got 20 minus 3, which is 17, minus 19i, and then divided by 26. And to put it in a plus bi form, you want to write them as two separate parts. And then this is just factoring. So if you're factoring over the set of integers, you're going to have x plus 3 and x minus 3. Real numbers, the same. Complex numbers, the same. The next one, you're not going to be able to factor it over integers, because there is no square root of 25. But you can factor it in x squared, because you can take the square root of 25, and then complex numbers would be the same. This last one, we have x squared plus 36. So if you remember, back here it said a plus bi times a minus bi gives you a squared plus b squared. And that's what we have here. What do we square to get 36? 6. So since we want it to be plus, we're going to have 6i. And then what you're going to do now is the homework. You'll get it done before class is over. It'll be fun.